All right, today we're going to pull back the curtain on this invisible rule that dictates how pretty much every app on your phone works, or sometimes, why it doesn't.
I mean, have you ever really stopped and thought about that? Why one service feels so rigid, but it's always perfectly accurate, while another one is just incredibly reliable, even if it feels a half step behind? Well, this isn't an accident, nope. It's a fundamental choice, a whole philosophy baked right into the code, and it's all governed by this thing called the CAP Theorem.
So to get our heads around this, let's just imagine the perfect app for a second. We're talking about a service that is always 100% correct, it's always online, and it works perfectly no matter what's happening with the network. That's the dream, right?
But, back in 2000, a computer scientist named Eric Brewer basically proved that in the real world, with these massive interconnected systems, that perfect digital dream, well, it's actually impossible. You simply cannot have all three. Something always has to give.
Okay, so let's really dig into this. What are these three competing properties? What exactly are developers being forced to choose between here?
All right, first up, we've got consistency. And you can just think of this as the absolute universal truth. When you transfer money, you want every single part of the bank's system to see that new balance instantly and correctly. Not most of the time, all of the time, no exceptions allowed.
Then you've got availability. And this one's pretty simple. It just means the lights are always on. You ask to see your social feed, you get a feed. You refresh the page, it loads. Now, it might not be showing the very latest like from a millisecond ago, but it's never going to show you a service down error. It just works.
And finally, we have partition tolerance. This is all about a system's ability to survive when parts of it get cut off from each other. So imagine the network cable connecting a data center in London to one in Tokyo gets physically severed. A system that's partition tolerant can handle that kind of chaos and just keep on operating.
Okay, so here's where things get really interesting. Because out of those three amazing properties, it turns out one of them, it isn't really a choice at all. It's a requirement.
See, the thing is, networks in the real world are messy. Servers crash, routers fail, cables get cut. It happens. So every major online service has to be partition tolerant just to survive. You just can't build a global service assuming the internet is going to be perfect 24/7. So P, that's a given. It's not optional.
And that brings us to the absolute core of this whole thing. If a system must be able to tolerate partitions, and we just established that they all do, it is forced to make this monumental choice. It has to pick a side in the war between the other two, consistency versus availability.
So when that network connection breaks, what does the system do? Does it choose to stay 100% correct by becoming unavailable, basically refusing to answer you until it's absolutely sure it has the right information? Or does it choose to stay 100% available, answering every single request, even if that means it risks serving you slightly outdated data? And this one choice, it creates two fundamentally different philosophies for building software. These philosophies shape our entire digital world. On one side, you have your CP systems, the champions of consistency. And on the other, your AP systems, the champions of availability.
So let's bring this out of the world of theory and see how this choice plays out in the apps you and I use every single day. Because this isn't just an abstract idea. This decision fundamentally shapes your entire user experience, and it's a direct reflection of a company's priorities.
So any system where being wrong is just not an option, they will always choose consistency over availability. Think about your bank, stock trading platforms, or a retailer's inventory system.
Yeah, their whole philosophy is built on trust, right? For them, it is so much safer to just show you an error message or make you wait rather than risk showing you an incorrect bank balance or letting you buy an item that's secretly out of stock. For them, user trust is everything, and correctness is how you earn it.
But then you've got this whole other category of systems. We're talking social media, video streaming, even the internet's address book, the DNS system. And they make the exact opposite call. They prioritize being online for you always.
For them, their business is built on engagement. Seeing a tweet that's 5 seconds old or a slightly out-of-date like count, that's a tiny price to pay for a service that never feels like it's down. An unavailable app means you're going to go do something else. So for them, uptime is everything.
Okay, so it sounds like a pretty stark choice, right? Correctness or uptime. But what if it's not always so black and white? As systems have gotten way more sophisticated, so have their ways of dealing with this fundamental trade-off. Well, this is where a lot of modern systems have gotten seriously clever. Instead of making one single choice for the entire system, many of them use this ingenious approach called tunable consistency, which kind of lets them have the best of both worlds.
So for instance, a database like Cassandra lets developers choose for each individual action. For something low stakes like fetching product recommendations, they can ask just one server for a super fast, possibly stale answer. No big deal. But for a critical action like processing your payment, oh no. They can demand that a majority or even all servers agree first. This guarantees perfect consistency, even if it costs a little bit of speed.
So the next time your banking app takes an extra second to load or even shows you an error, you'll know why. It's not a bug. It's a deliberate choice that system is making to protect the integrity of your data. And when your social feed loads instantly, you'll know it's making the opposite choice, to prioritize keeping you engaged over being perfectly up to the millisecond correct.
And really, that's the whole thing. Every single digital service you use has made a sacrifice, right at its very core. It has chosen a side in this great trade-off between being right and being ready. And now, you have the framework to see exactly which choice it was.